We're going to start looking at how experts solve problems and teach you how experts solve problems so you can solve problems like experts can until you become an expert yourself. Whenever an expert comes across a problem, they're going to start by sketching as much as they can. We can call this a bunch of different ways, visualizing, diagramming, and things like that. So what we want to do is we want to try to draw, a drawing of the problem. And we could maybe have a before and after, or maybe we could have multiple views. We want to understand what's going on, and the easiest way to do that is to activate our brain by having it look like something in the real world, instead of it just being problems on a page. Then what we can do is we can add diagrams that abstract the problem. So in this week, we'll be learning about motion diagrams. We'll also be learning about graphs, another type of diagram that is another way that's not the real drawing or understanding of it, but is another way to approach the problem. Once we have our sketches, then what we do when we solve is we begin to organize. And how we organize is we want to write down known and unknown quantities. When we say unknown, we usually mean the things that we are solving for. Oftentimes we'll have to solve for things before we're able to solve for our final step. So we're going to call all of these things just unknown quantities. Of course, there's a lot of unknowns that we might not need to solve for. We don't want to write too many of those. We kind of want to stick to that. We also want to write down relevant relationships. So in our first couple of weeks, we'll be talking about the kinematic relationships, kinematic equation 1, kinematic equation 2, other things like that. And so writing those down really helps understand what's going on with them. As we go further on, we're going to write Newton's second laws or conservation equations, things like that. But these relevant relationships are really going to help. And then what we want to do is we want to try to find relationships with relevant unknowns. And we want to kind of diagram and understand what's that's going on. What we can really say when we're doing this is we're trying to find which equation to use. So if we've done all that, then we've organized ourselves quite nicely, and we can go into this third step, our solve step. As we do the solve step, we are going to take the equations from our organized step and we're going to use math and manipulate the relationships to solve. What's nice is we have done this before in other classes. We have done, using the math equations in math classes. We've done taking math equations in other science classes like that. What we haven't really done is back here with our sketch and our organized step. So once we get here, it's going to feel a little bit like home base. It's going to feel a little bit like a lot of other previous classes. So we want to get as much practice with our sketch and organized steps before this as we can. Then, once we've solved, we want to check our answer. And ways to do this is dimensions or units, If we find out it has the wrong units, it's a very good sign that we did something wrong, either in the relationships defined or the math that we did. And then if the answer makes sense, is something that a lot of books will say, and I'll say too, but it's really hard because we don't know what makes sense just yet. But just try to think about it. Think if this specific thing makes sense in a speed and a distance and things like that. Just look at the number and try to convert to English if you're not comfortable with metric, or think about it in a metric sense of, right, what this makes sense for. So this is what we're going to be doing every single chapter, every single week, is just doing a different idea of sketch, organize, and solve.